Namaskar, myself Professor Arvind Bhatt. I am in Department of Mathematics, School of Science, Uttarakhand Open University. Today's topic of my lecture is probability. The history of probability is Galileo, an Italian mathematician, was first researcher solved the some problems related to the theory of dice in gambling. After that, explained by two French mathematicians B. Pascal and P. Fermat, and Demer put a question in front of Pascal. Chevalier Demer put a question in front of Pascal. The famous problem of point posed by Demer to Pascal is two-person play a game of chance. The person who first gains a certain number of points win the stake. They stop playing before the game is completed. How is the stake to be decided on the basis of the number of points each has won? After that, many researchers, J. Bernoulli, N. Bernoulli, De Moivre, T. Bayes, P. S. Laplace, Levy, R. A. Fisher, Chebyshev, Markov, Lyapunov, and Kolmogorov, who assumed the calculus of probability. The basics of probability. We first familiar with permutation and combination. Permutations. A permutation is an arrangement of objects in a definite order. The number of permutation of n objects taken all at a time, denoted by the symbol, is given by npn equal to factorial n. The number of permutation of n objects taken r at a time, where r from 0 to n and including, denoted by npr, is given by npr equal to factorial n upon factorial n minus r. Combinations. A combination is a selection of some or all of a number of different objects where the order of selection is immaterial. The number of selections of R objects from the given n objects is denoted by NCR equal to n factorial upon R factorial into n minus R factorial is equal to NPR upon R factorial. Basic terminology: what is random experiment, what is outcome, what is trial, sample space, exhaustive events, favorable events, mutually exclusive events, equally likely events, independent events. When we rolled a dice, rolling a dice and observing the number showing on a dice, the sample space is S equal to 1, 2, 3, 4, 5, 6. If we rolled a die, we observe the number 1, 2, 3, 4, 5 and 6. And the set of these numbers are called the sample space. Rolling 3 coins. A coins have two sides, head and tail on the sides. Rolling 3 coins simultaneously and observing the face of coins, the sample space is H, H, H. We are assuming that all 3 coins are heads. When 2 are heads and 1 is tail, H, H, T. And when first is head, second is tail and third is head, then STS. When first is tail, then another second are heads, THS. First is head, another two are tail, head, tail. Then first is tail, second is head, next is tail. TST, first 2 are tail and next is head, TTH, and all 3 are tail, TTT. Rolling a dice is a random experiment and each rolling of this dice is a trial. The total number of possible outcomes of a random experiment is known as the exhaustive events. 2 events are exhaustive when their union is equal to the sample space. The number of cases favorable to an event in a trial is the number of outcomes which entail the happening of the event. It means we observe that first event, random experiments and sample space are the main key points. Events are said to be mutually exclusive or incompatible if the happening of any one of them precludes the happening of all the others. Equally likely events in probability are events that have an equal chance of occurring. Two events are said to be independent and the occurrence of one event does not affect the probability of the occurrence of the other event. Now, the basic definition of probability. Before probability, we are assuming that we are familiar with permutation, combination, event, random experiment, sample space, favorable outcomes, and mutually exclusive, mutually inclusive. If a random experiment, the experiment are random. If a random experiment or a trial results in an exhaustive, mutually exclusive, and equally likely outcomes, out of which M are favorable to the occurrence of an event E, then the probability P of occurrence means or happening, of E, usually denoted by capital P, is given by small p is equal to capital PE, probability of events. It means probability of events called PE is equal to number of favorable cases upon total number of exhaustive cases. It means total number of exhaustive cases are the sample space is equal to M upon N. Total number of ways of happening of an event is number of cases favorable to the event E, and also called the number of sampling point in E. Similarly, total number of outcomes is number of sample points in E, and also called exhaustive number of cases. Now the example. Two unbiased dice are thrown. Dice, first in your mind you assume a dice, and the dice are unbiased. Two unbiased dice are thrown. Find the probability that first, both the dice show the same number. Second, the first die shows 6. The total of the sum of the numbers on the dice is 8. The total of the numbers on the dice is greater than 8. The total of the number on the dice is 13. And the total of the number on the dice is any number from 2 to 12, both inclusive. In a random throw of 2 dice, since each of 6 faces, every die has 6 faces. It means one die can be associated with each of 6 faces of the other die. The total number of cases is 6 into 6, 36, as given below. The matrix given below. 1, 1 in row. 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Here the expression says I, j means that the first die shows the number I and the second die shows the number j. Obviously, ij is not equal to ji if I is not equal to j. If I is not equal to j, I, j is not equal to j, I. Therefore, the exhaustive number of cases n, small n equal to 36. The solution of first is the favorable cases that both the die show the same number. The number of die is 1, 2, 3, 4, 5, 6. Second die is also 1, 2, 3, 4, 5 and 6. It means the cases are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. It means small m equal to 6. Number of cases are 6. Therefore, the probability that two dice have the same number, using the definition of probability, number of favorable cases upon total number of outcomes is equal to 6 upon 36. 6 divided by 36 6 times is equal to 1 by 6. Solution second, the favorable cases, the first die shows 6. First die shows 6 and second die shows 1, 2, 3, 4, 5 and 6. Here also 6 cases. Therefore, the probability that the first die shows 6 equal to 6 upon 36 is equal to 1 by 6. Solution 3. The favorable cases to getting a total of 8 on the two dice are 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, m equal to 5. Therefore, probability that the total number on total two dice is 8 is equal to 5 upon 36. Solution 4, the favorable cases to getting a total number of more than 8 are 6, 3, 3, 6, 6, 3, 4, 5, 5, 4, 4, 6, 6, 4, 5, 5, 5, 6, 6, 5, 6, 6. M equal to 10. Therefore, probability that the total numbers on two dice is greater than 8 equal to 10 upon 36 is equal to 5 upon 18. In solution 5th, we have to find out the probability of events. The total of the number on the dice is 13. This is impossible because the maximum is 6 plus 6 equal to 12. Therefore, the required probability is 0. In a solution 6, the probability is 1 as the total of the number on the two dice certain from 2 to 12. The given event is called a certain event. This means there is a 100% chance that the event will occur. The event are certain when the probability equal to 1. So then this is a basic lecture. We have learned about the basics of probability. We knows that the basics of probability are permutation, combination, events, sample space, and the definition of probability. Using the definition of probability, we have solved a simple example. Next lecture, we also continue this lecture. Thank you.